Today, I'm pleased to introduce the session, A Beginner's Guide to Building a RAG App with using open source Milvus, and today's guest speaker, Stefan Batufol. Stefan is a developer advocate here at Zillow. It's nice to work with a colleague on these webinars. So he previously worked as a machine learning engineer at Volt, where he was working on the ML platform, and as a data scientist at Bravo. Stefan studied computer science and artificial intelligence, and he enjoys dancing and surfing in his off time. Welcome, Stefan.
Thank you very much for the intro. All right, so yes, today I am here to talk to you about the beginner guide on building a RAG application using Milvus. So as said before, I'm Stefan Batufol. I'm a developer advocate at Zillow. You can find all my socials here if you want. If you have any questions related to Milvus, related to RAG, feel free to reach out to me directly on LinkedIn, directly on my email, or on Twitter as well. So yeah, let's go. Let's get started. So RAG, I guess if you're here, it's also because you want to know what it is. So RAG means Retrieval-augmented generation, and that's what we're going to talk about today. So the basic idea of RAG is that, you want to force your LLM to work with your data, and you usually inject it via a vector database like Milvus. Let's say you have your LLM, and if you used OpenAI and you use ChatGPT, for example, you might have seen that, there's always a cutoff date. And then after that, your LLM doesn't know about what has happened. And also, if you use private data, your LLM doesn't have access to your mails and different things like that. So for that, usually you use RAG. And how it works is that vector database, they provide the ability to inject your data directly and via semantic similarity. And that's how it works, and that's why you always have vector database using for RAG. So then you have different things to take into consideration. If you use RAG and vector database, the scale, the performance, and the flexibility. Obviously, you don't want to use a vector database if you're going to have you don't want to use something that doesn't scale if you have millions of vectors and different things like that. So yeah, take that into consideration your site. And problem is that LLMs are stochastic, so they always predict the future token. And that's cool, but that's also why, sometimes you have different answers with the same question. So that's a problem you may have. And a downside as well is, I mentioned it before, you might have outdated input data. So that can cause some hallucinations. And for the people who don't know what hallucinations are, it's something that sounds like it's true, but it's factually incorrect. So you're going to ask an LLM about, I don't know, where someone is born, and they're going to be very confident that this person was born in New York, even though this person was born in Chicago, for example. So that's a problem. And this is a basic RAG architecture, I would say. So you always have your data. That's how you start. Then you're going to extract the content from your data. So if you have some PDFs, then you're going to try to extract the content. Same if you have some videos, same if you have different things. Then you're going to chunk your data. You're going to put that into an embedding model. And I will explain those later on different slides. So no worries if you don't know what it is. Then you store everything in Milvus. And then once you make your query, then you also have to make your query go through an embedding model. And then we run a semantic search. And then your LLM will then know about similar data, and then we put everything in the context, and then you get the results. So that's the basic RAG architecture. And yeah, chunking embeddings, you'll see, are very, very important. So the tech stack for this one, it's LangChain. Then I'm using embedding models directly from Hugging Face, from Sentence Transformer. I'm using the Milvus for the vector database. And I'm going to run everything locally. So I'm going to run Llama 3 directly on my laptop. And also, yeah, for this RAG app, something I didn't mention is that everything will run locally. Everything will be free. There will be no OpenAI or any other models. So LangChain, what it is, it's a framework to build LLM applications. And it's mostly focused, I would say, on retrieving data and integrating with LLMs. So it's very useful if you have to load some data. Let's say, you want to load some PDFs. Your PDFs might be local. They might be on your computer. They might be, I don't know, on the internet. Well, they make it very easy for you to get those PDFs wherever they are. They also make it easier for you to chunk your data and to have like some different configuration with a chunk overlap. We'll see later what it means. So those are like very handy. And then they also have integration with like the most popular tools you can think of. So it's also, they make it very handy for you if you need to use embedding models from different companies. Then you usually only have to change the import file. So that's LangChain. Then you have Olama. So if you've never used it, it allows you to run LLM locally, and it's very handy. It only runs quantized LLMs though. But then Llama 3, the smallest version, can run on my laptop. It takes about 4 GB of RAM. And that way you don't have, you might be able to use it when you're on the plane or when you're somewhere. They also allow you from recently to run embedding models. So it might be something that is very interesting. So yeah, if you want, you can download Olama, and then you'll be able to run Llama 3, but you can also run different models. They have a lot of models available. Milvus, which is a vector database, so it's cloud native and distributed system architecture, has true separation of concerns, and it also has scalable index creation strategy. I won't go over the details with the different segments, but it's made for scalability. And then we have embedding models in general. So as I said before, for this one, I'm using one from Hugging Face, directly available. But depending on your needs, you might want to use different models. So let's say if you work with documents that are in a different language. For example, I live in Germany, so most of the documents are in German. Sorry for that. So then you might want to use embedding models that are specialized in German language. It's the same if you want to use videos, you might want to use embedding models that have been trained on videos. And so then, yeah, I highly encourage you when you start something to check out different embedding models. Usually you have a leaderboard on Hugging Face, but they also have like list of like different embedding models for like different use cases. So don't always go for OpenAI embedding models, just because it's very good for generic things, but for specialized things might be a bit tricky. So yeah, you have a lot of different ones. So yeah, let's go a bit more into details into embeddings. So the first thing that I already mentioned is that when you use embeddings, you have to pick a model. And again, to repeat what I said, it's very important to pick an embedding model that has been trained on the data you have. So if you have one that hasn't been trained on videos, then it might not work. If you are going to use Japanese text and it has been trained on English only, it's very likely it will not work out as well. Then you have to choose what to embed. And then you have the metadata, and I will go into that a bit later as well. So yeah, different embedding strategies. So there's level 1, which is like embedding chunks directly. So you have your data, and then you split your data into smaller chunks. And you might want to just embed the chunks, and then you put everything in a vector database, and then you can do similarity search. That works. It can work very well depending on your data. But then you have another level, which is level 2, which is like embedding sub and super chunks as well, which can usually provide more context for your data and for your LLM to understand what's happening. And then the other level is like incorporating chunking and non-chunking metadata, sorry. So you can be like, you can have like metadata that is all about the author and everything, and that can be like very important to be able to understand your data. And as examples of like different metadata, so for like chunking, for chunking metadata, you have like paragraph position, section header. If it's like a larger paragraph as well, you might want to chunk that. Sentence number. So those can be very useful. And then the non-chunking one are like going to be like, okay, who wrote this, publisher, the organization, and different things like that. And usually those actually provide very helpful information for your RAG app. And you might be wondering, okay, so what does it look like then? So that's what happens when you pass your data through an embedding model. Like here, we have an example of a text, and then we pass it through an embedding models, and then you get your vectors in the end. Like that is only after it goes through an embedding model. And then, yeah, you have your vectors, and that's what we're going to do. We're going to run similarity search on the vectors, and that's how it communicates. That's what vector database do. That's how we understand everything. And so yeah, takeaway for this one, the embedding strategy really depends on like the accuracy you want, the cost, and the use case needed. Those are like there's no real one solution, one fits all. So yeah, have a look at different embedding models. It might be very useful for you. Then there's chunking. So as I said, like you have to take into consideration different things. So the chunk size, how long do you want your chunk to be? Do you want it to be like one character, or do you want it to be 1,000 characters? It depends. There's also the chunk overlap. So it's going to be the overlap between two chunks. So sometimes it can be useful so that you understand, what's happening between your chunks. And also character splitters. It might be very interesting. If you have like a comma or something, or if you have a dash, might be very interesting to like split on dashes, for example, depending on what your data looks like. And as an example, you can see here, so it's the data we have, and it's actually the data I'll use later during the demo. But here we have a chunk size of 50 and an overlap of 0. And you can see, so I just added myself the text is here. But you can see that the data is not really, you don't really understand what's going on, Like nothing really matters. Like here, you don't have like June 30th. There's nothing that really is important. So your LLM will also struggle to figure things out. Another example is like chunk size of 128 with an overlap of 20. We can see here that we start to understand what's happening, what's going on, and also you can see the overlaps. You can see that, for example, for the first chunk, it finishes for the quarterly period ended June 30th, blah blah blah, and then it's here the same for the second chunk. It starts with that, so that's the overlap. And yeah, here you can see like okay, it starts to be more interesting. But then you can obviously go higher, chunks out of 256, overlap of 50. And this one starts to be, okay, way more interesting for us. You can always go higher. So then it's also like, usually people ask me like, oh, do you have like specific number you use? And unfortunately for now, there's nothing, like we don't have a specific number. It really depends on your data. It really depends on what you want to chunk. There's something that I'm using from time to time, which is semantic chunkers. They are available on LangChain and Llama Index, and they can be very useful for you. They're going to try to figure out that's the meaning of your sentence, and they're going to try to gather everything together. Everything that makes sense, everything that is similar, they're going to try to make one chunk out of it. The thing is that if you want to use semantic chunkers, you need to use an embedding models. Whereas the previous one, it's a very stupid way. It's like it's just going to read the characters and then it's going to split. So yes, that's like, I find it to be usually better to have better results, but then you have to use an embedding model for it. Also, something that is very important is like, how does your data look? Is it mostly conversation data, or is it documentation data, or lecture or Q&A data? If it's documentation data, you can already have some chunks of, them. You may be able to have a paragraph, and then you want to have, like some super chunks. So you want to add some information about the title or the heading. Those might be very useful for your data and for your chunks. Same for lecture or Q&A. If it's a Q&A data, you might have at the beginning of the sentence, you might have something which is like question, and then the actual question, and same for answers. So then, it would probably be a good idea to have chunks that are like divided by like question and answers. Okay, so you don't have to do like every 256 characters, for example. So yeah, unfortunately, there's no like amazing number. So it's only the strategy depends on what your data looks like and what you need from it. And now I'm gonna go into a bit more of a demo. So those were the slides, and they will be available later, so no worries. But yeah, I'm gonna go into a bit of a demo here. And as I said, everything will run locally. So I have my Python environment, which is here, and I'm using Docker Compose version of Milvus. So we're just gonna start it. It should already be running, actually. So yes, then it starts the different components of Milvus, and now we should be good. If we look, everything is here, everything's running, everything is healthy. So now we're happy. I have a notebook ready as well. So that's where I will be running my code. So just to show you, this is the Docker Compose file. You find it on the Milvus documentation directly, so you don't have to make it yourself, obviously. And yeah, so this is the code. So the first part is where I'm going to import everything I need. So as I said, I'm using LangChain. So then, like I'm using the different components of LangChain. So the first part is the PDF loader, but I'll go into more details later. To make sure and to not lie to you, actually, I have this piece of code here, which will actually drop the collection if it exists already. So I'm just going to run everything. So the collection has been dropped. So then I actually have to recreate it, and that's what we'll do during the demo. So this part here is where actually I'm going to load the PDF. And as I said before, LangChain makes it very easy for you to load a PDF that is either local or on the internet. And I'm going to show you what the PDF looks like. Yep. This is a PDF about WeWork. And yeah, so that's like, it's a very long PDF. It's 169 pages. You can see it's like a lot of financial information, a lot of different things. And this is the PDF we're gonna use for the demo. So I say, okay, go get this PDF, please. And then I load it. So I use the loader and then I actually load the data from the PDF. So now it's gonna go to this PDF on the internet, download it somewhere, and then it's gonna load it into my memory. As I said, also I'm using Hugging Face embeddings. So those are like sentence transformers. You're free to use different models. Those are the ones that I decided to use for the demo. They're pretty good for text in general. And yeah, they're not too big as well. So it's a very nice embedding model, I would say. So now that's what we're going to use later to then transform our data. That is the PDF that you've seen before to transform it into vectors. Then, I was always talking about like the chunk size and the chunk overlap. So that's exactly what I'm doing here. This is what I have. I'm gonna do stupid chunk. So it's only at every 52 after 512 characters, sorry. You will have a new chunk. There's nothing smart about it. So that's what you will have. And I'm saying, please run this chunker on the whole document. So that's what it's doing. It's splitting the document into different documents, and then we have all the splits. So if I show you, I can show you the splits. This is what it looks like. You can see that it created different documents, and then a document is basically a page. And then you can be like, okay, this is the content, and blah, blah, blah. And then it's saying, okay, the page is page 0. It also added some metadata, which can be very useful for you. For this one, it's not very useful because it's just a PDF on the internet, so it's only the URL, but it can be like, you can also add different metadata if you want to. And then, yeah, again, it's going to tell you which page it is and everything. So those are those splits. Let me just remove this one. Up. And here is where we're going to put all our splits, the split that I just showed you before. That's where we're going to transform them, and that's where we're going to store everything into Milvus. So I have all my splits, which are the documents split into chunks. I have my embedding model, which I define here, which is again the Hugging Face embedding model. And then I'm saying, please create a collection. Please use the collection that is RAG Milvus webinar. And that's the name of the collection. And it's the one that I dropped before. So I'm going to run that. That's going to take a tiny bit of time because you have to transform everything. So the data now is being, like you run the data into your embedding model, which generates vectors, and then we store those into our vector database, which is Milvus. Here, I'm defining a retriever. So that's what I showed before, like on the slide where you're going to type your query and then, you need to do some semantic search. So that's what it's going to do. Like it's going to send the data of a query directly to the embedding model, which then is going to talk to our vector database. So this is what I have for the retriever. The prompt here is it's just a typical prompt you use usually in RAG, which is usually like you're an assistant. Please, if you don't know the answer, say you don't know. the answer so that you don't hallucinate. So yeah, that's what we have here. Now, I defined Milvus as a retriever. I'm going to define my LLM, which is coming from Olama, which is Llama 3. This is what I have here. This is just detail, but Llama 3 has a specific token to say that it's stopped, to say that it is like over. So I'm just saying like, please stop every time you see that one. Otherwise, usually Llama 3 continue talking to itself, which makes it funny, but it's not what you want for your RAG. Here, it just to format my document so like it looks quite nice. And here's the RAG chain. So this is where you have all the magic, basically. So you say, okay, as a context, this is my retriever. The question is the question that will ask you later, which is the one you see here. So you just give it to your RAG, and then LangChain is doing the magic for you. And then, yes, the prompt is what we pull here. So it's saying you are an AI assistant, blah, blah, blah. And then you're going to give that to your LLM, and then you're going to have an output. So that's what you define the RAG chain. And I have a document, I have a question already ready, which is what is WeWork? Because the document is about WeWork. And so then you can see directly what is it saying. And that part is a bit slow because first I'm running everything locally. And then it's when, you give the context to your LLM and the LLM has to find everything. And yeah, here it's like it's gonna tell you about WeWork and everything. And I can also you could also be like, okay, but maybe the Llama 3 knows about WeWork, so it could also be just like nothing that is related to this document. But then I can just ask questions directly. What is this document about? And usually it should tell me like the document is about what we saw. And yeah, exactly. So I was saying it's a financial report. So then it's saying, yeah, it's a quarterly report by company. And then that's it. You can then ask different questions to your LLM. And that's basic RAG application that you have. And it's a basic one that you like everything is running locally. You don't have to pay for anything. Everything is actually open source as well. So then if you have any data, if you want to build your RAG system, that is something you can use in the future if you want. Also something that is quite cool is that LangChain allows you to like add sources to the answer. So you can be like, okay, please like add the source of your answer. So that way it can help a bit to check for hallucinations, to make sure that it's actually like, not making something up. And here you can be like, okay, the context, this is what the context we gave and everything. And it can be like the source. You can see the source is directly the document that we had before. And it can be like, okay, this is the page 12. This is the page 69, page 670. So yeah, that's something that is usually I find very interesting. Adding source. So yeah, like especially for your private documents, that way you can always make sure that the LLM is not making something up. And that's kind of it for a basic RAG application. So I can take questions now. I haven't seen the questions. But yeah,
We do have
thank
some
you.
questions. Thanks for the demo. If this is a question from the audience, if I embed my vectors with OpenAI, then embed the query with another model like Hugging Face, will the response still be semantically similar? Essentially, can you use different embedding models and still get distance between results in a meaningful way?
You can use different embedding models, but then it also depends on like what would be the idea behind it. Is like, I guess if you use an embedding model, specific one for your question, is there a different reason why you wouldn't use it for your data as well? Like you might have, it's possible, but you might have very different results. Like they might not be as good because
There was an additional clarification for legacy data.
for what, sorry?
For legacy data that's embedded with OpenAI.
For legacy data, yeah. Yeah, you could, but then it's like I'm not going to guarantee there is the quality of the results, basically.
No. Okay, oops. Okay. If we did not answer that question fully, I see that there's a couple extra comments. Feel free to submit again. Moving on to another question. When using Ollama in the notebook, is it loading a quantized version of the model, or is the Docker Compose already running and Ollama on the notebook is connecting to it?
No, so it's running a quantized version on my laptop, and then Ollama starts a server, which then the notebook connects to the server directly. So I basically have a local Ollama server on my laptop now running, and everything is quantized. Yeah.
There has been a request of, is it possible to get the code?
Yes, it's actually on my GitHub. I'll share the link directly after it's already up.
Perfect. And we'll include it in the follow-up email as well when we send out the recording. Is there another question? Is there a smarter way to chunk if an embedding model is used? I thought you said it wasn't necessary if an embedding model is used.
Yeah, so there's the semantic search, semantics chunking, sorry, which is shown here, which this one requires an embedding model to be used. So because it has to figure out, the meaning of the sentence. So yes, for this one, you need an embedding model, and it's usually smarter to chunk that way. The other one, this one, is the stupid chunk, which only, like splits everything after X characters.
It says, thank you. Is there an example of the semantic chunking?
Yes, I don't have it here directly, but I have it somewhere
Okay.
else on another code base. Yes.
Okay. And we can send more. We can send more in the follow-up. So here's a question. How do you usually evaluate your models?
It depends. On my side, I like to have answers that I know that are true. So usually I will I will talk to my model and I'll be like, ask questions, very specific questions which I know are true. And then I'm gonna check the answers. Then there are like different evaluation models, there are different ways of evaluating a model, but yeah, that's usually the way I do it. For like usually 10, 20 answers that I know that are true. Like I have an example for, I work with the Berlin Parliament data, and they still use fax machines, and I know the exact number, the exact amount of services that have to use fax machines is 189. So then depending on the embedding models I use, depending on the LLM, I don't have the same answer, but I know the real one is 189. So that's what I check.
Is there a way to extract semantic concepts from text as a vector representation using an LLM?
Can you repeat the question, please?
Yep. Is there a way to extract semantic concepts from text as a vector representation using an LLM?
I'd say so, yeah. That's what happens when you pass it through an embedding model. Like you get your text, and then like you have your embedding model, and then it's gonna make you some like it's gonna try to figure things out and try to make some sense out of the data, and then you have your vectors.
Here's another one. How do we solve the problem? For example, in the PDF, there is some information which is related but expanded on multiple pages. So how do we get complete information while querying results? What chunk sizes and
Good.
overlaps should we use?
Yeah, good question. That's like when you have to play around with the different overlaps with your chunks, and that's like you'd be like, or maybe like you're gonna chunk some metadata. Maybe you're gonna chunk like you're gonna have your like small chunking of like 512 characters, for example, but then you also want to embed your metadata about like different about your document, or then you can embed like super chunks as well, so like a small part of your document and then have some super chunks. What I like usually is the semantic chunkers, because they might be able to figure that out, but then it also means like you have to, when you split your data into different pages, you have to make sure that then they understand they're on different pages, and maybe try to remove like those different pages, like try to have your text as one part, or things like that. But it's unfortunately a lot of trial and errors. For now you don't really have anything that is like magical.
So and this is my own question. So because you can specify the chunk size and the overlap, would you do sort of a similar thing where you were talking about, sort of testing your LLM where like you know that there's certain answers, or are you kind of using the same premise of you know what you're expecting to see, and that's how you would kind of check your chunk and overlap size, or is there a better way to sort of confirm that you've split it correctly?
Yeah, usually that's what I do as well. It's like I'm actually gonna ask some questions which are to the end of one page, for example, and then continue on the other one. And then I'm gonna check, be like, hey, did you figure that out by yourself, or like can you actually figure that out? And then yeah, usually with the chunk overlap, it can be useful because then you can continue. But then yeah, it's just a lot of trial and errors usually.
How are you running Olama in local? Is it less size? I think smaller.
It's 4 GB for the smallest version of Llama 3. Yes, so
Um,
a lot of laptop can run it.
how well can LLM models with RAG help to review and answer law-related questions?
Which question? Sorry.
Law-related?
Ah, good question. I think it can be very good, but it's also like I mean, they're just usually usual data. You just have to make sure it doesn't hallucinate at all. So the good part is like maybe like, making sure that you always have a source, like, really double checking those, like with the source that you have, like the answer you have, then checking the source and be like, okay, does it actually exist? Is it really a thing? Those usually work. And then low is what's nice is that, it has a very specific format. Low is very strict on the format of the documents, so that usually you can like your chunking might actually be good or way better than like any other documents because you can actually split documents. Like your logic, it makes sense in the document. There's a logic. So those are like things that can be really helpful. But I would say, yeah, have sources and check the sources of your LLM when it like gives you an answer.
And I assume that the same would hold true, that you would want to make sure that you found a model, like you would want to be specific in um, what you choose. That was sort of like that you're using like embedding models that are trained on law, and then sort of be thoughtful about the LLMs you're
Exactly,
using.
exactly. Like if you have a embedding models that have been training on that kind of data, it's way better. And yeah, it's also the kind of thing where you need something that is like in your language. So if it's in English, then find one that has been trained on, English law data, different languages as well.
When do we need to use token-based chunking compared to chunking per characters?
Honestly, it depends. I don't think there's like a real right answer to that, unfortunately. So chunking is gonna depend. Uh, I usually don't go for token based. Just it's my personal preference. I didn't find any like performance improvements. So yeah, only depends on your side.
To clarify on the question regarding switching embedding models, are you saying that we don't know if the old legacy data will still allow the model to get semantically similar responses? We
No,
would just have
no,
to test or re-embed all of the old legacy data with the new model we've chosen.
no. It's I mean, first it's also like yeah, you'll have to be careful because your first model will give you like will vectorize all your data. Then it will be a certain dimension, and then the other data might be like a different dimension. So you might run into a problem here, and then if you solve that, it's just like I'm gonna give a very stupid example, but if your old embedding model has been trained on Chinese, and then the other one is like trained on English, then they're like technically they've been vectorized, but then they have like very different meanings because you use like a different embedding model. So like you have to be careful that they can kind of work together if you see what I mean. It's like yeah, like you have different embedding models. So yeah, make sure that they are like been trained on the same data and like different things. But then also like you have to then work with the different dimensions.
Is the approach for multimodal RAG or for a multimodal RAG application similar?
Yes. Yes, it's very similar. It's the same. You just have like your chain will be a bit more complicated, but then multimodal otherwise will be the same. It will be like you have different embeddings, different models, um, and then depending on like what you have, then you're gonna be like, okay, this is my chain. There's an image, there's text. Then you have to go through. a different path. But yes, it's very similar.
And we've had another request for we will share the GitHub info when we send out the replay. So you'll get that delivered straight to your email. So you will get that and we'll send a link to the slides as well. Is it possible, I've heard this one before, is it possible to get the original data back from the embedding vectors?
It's an approximation, so you can like I don't think it's possible to like revert directly. Tell me if I'm wrong, but yeah, it's an approximation. So you can usually be like, oh, okay, but no, you can't really like reverse it.
I think that was an early concern, particularly of big companies that were starting to do RAG proprietary data. Okay, next we have, how do you refine the concepts, for example, for domain-specific concepts when extracting concepts from text? For example, if you have very domain-specific concepts you're trying to find.
Okay, maybe make sure I get the question right. So if you have some very specific concept in your document, do you think that's what it means?
There's a follow-up question from the same author. It says, how do you train an LLM for domain-specific knowledge?
A training LLM for domain-specific, usually I would say you fine-tune the LLM with like your, like your personal data, like your, I don't know if you work in the world of cars and you have a lot of car manuals, you might want to fine-tune it directly, which can be also quite expensive. Fine-tuning an LLM can be like very long task. Not as long as training one, but it can be very long. So then the other solution, which usually would be like, have like RAG application for your specific data. So if you have like, again, with my examples of cars, inject like manual data, manual cars, and then put it in your vector database. And then you can have like something that is very specific for your context.
And if we didn't answer a part of that, feel free to resubmit, but I think we got that one. But yes, if we missed any component of that question, please resubmit. Here's another one. How do you improve the performance of LLMs?
Wow. So I'm gonna assume like on these contexts for like RAG in general, the two things, chunking and embeddings, usually are like really the key. If the question is about LLMs in general, that's a very deep question. But for RAG, it's really like, yeah, make sure your embedding model is the correct one. Make sure that, like you have the same data. If your goal is to detect pictures of, if to detect cuts in pictures, you have to make sure that, that has been trained on that. And then, yeah, chunking is also a big difference. Like, I show this one, like chunk size of 50, overlap of 0. Clearly, you can see that nothing makes sense. You probably have no idea of what's happening. Maybe, if you read quarterly reports in the past, you can. But an LLM wouldn't be able to figure things out. Whereas if you have semantic chunker, you have sentences, things kind of make sense. So yeah, basically those are usually the two that you're like, have to be very careful.
Thank you. The questions just keep rolling in. Popular topic. There are a lot of advanced RAG techniques. Which ones do you find very useful?
Yeah, it's on my side. I think it depends. Depends on my use case. The best one, I mean, the one I've seen the best so far, have the best results, is like I tend to keep my RAG apps simple. I just no doubt on the embeddings. So that's usually like, I find it to be better to like have better result than like going really, really into like really deep RAG, systems. That's at least from my personal experience. I feel like, with different embeddings and really like finding the one that is like really good has usually better results.
Mm-hmm. Just to add on to tag onto that question, are you using any like evaluation tools to evaluate your RAG, or is there anything that is top of mind that you like to use or is kind of a go-to?
Yeah, I feel like so there's a thing of like using LLM as judge. That's something that is quite quite nice. I've been playing around with Ragas recently, and I want to also try Phoenix, which are like evaluation tools. Um, and so yeah, those are like I tried with Ragas and it was like quite nice, but I want to try with Phoenix to see like if you can like make my life easier as well, so that I don't have to do it myself. Like checking things directly, but yeah, using an LLM to also judge your LLM.
Yeah. And on
Or
that
your
topic,
RAG.
we do have a past webinar from the Arise team about using Phoenix for evaluation. So I'll drop a link to that in the chat. But that's if you're interested in RAG techniques, advanced RAG techniques, that's probably a good session to
Mm.
watch the replay. So I will share that with you in just a second. Can we do RAG for CSV Excel data sets? If yes, then how do we split these data sets?
So I haven't tried with Excel directly, but CSV, yes. I assume that FluentChain has like integration with so many different document types that it's possible. One example, like they can do for Notion pages and different things. So like CSV, then you would have your delimiters, and then it depends on what you have like content in your CSV as well. It's like I don't know. In CSV, you have like so many different kind of content you can put in. That it depends, but yeah, otherwise it would be the same. Like you have some delimiters, and then which are your commas. And then depending on that, you have to figure things out. So then depending on your data, if you have like, I don't know, 10 columns, and then in 9 of them you have like, numbers which are, not very relevant to you. And only in one, then you have the text, which might be very relevant for your RAG app. Then maybe you want to only use that one. And then you chunk on this specific column. So yeah, CSV and then Excel would be the same. I assume they have an Excel connector. They have connectors for everything. So yeah, it's same but different, as we say.
Let's see. Just checking in the question feed one more time. I'm going to drop that link into the chat really quick. Makes sense. Do vector in structured data like in a large SQL database, fine tuning or a multi-agent system will be a better choice? Not quite sure I
So
understand that one.
okay, what's the beginning of the question?
It says, I think makes sense. Do vectors in structured data, like in a large SQL database, fine tuning or a multi-agent system will be a better choice? If you might want to resubmit more detail to the question. I think we're missing a piece of it. While we wait for them to clarify the question, I'm just going to drop in the link to the replay of from Arise, the webinar from Arise on using Phoenix to do RAG evaluations. And Phoenix is open source as well.
Yes.
There you go. Okay, let's see. Are there smaller LLMs that can be less expensive to fine tune and maybe run locally?
Yes. We have a lot of LLMs available. Then it really depends. Depends on your use case. You could also fine tune them locally if you have time. But it's always possible. You have like some very, very well, I don't know if they're then LLMs, but you have LMs, language models. So smaller ones which can be decent. It really depends on your use case. And also check out check out on like Hugging Face and everything. You can see people that are fine tuning classical LLMs. Like Llama 3 has been fine tuned on different things. So for like function calling, it's been fine tuned. So like check out what the open source community is doing, and maybe someone is already doing the work that you want to do.
So this is my own question. I would like to know, when you first started building your first RAG apps, where did you go wrong? If you could kind of go back and give your past self advice on what to do or what not to do, I think that
Yeah,
would be really helpful for our audience.
sure. I think the first thing for me was really like I had no idea what chunking was, or like how it would like work and like I could actually make it work. And then I was just chunking on like every. I think at first I was chunking on every space. which is, like then nothing makes sense. Basically, when you build like your first RAG, if you can't figure it out yourself when you look at the data and you look like, what you're feeding to your LM, usually it's very hard for your LM to then figure things out. Obviously, it's possible, but it's really hard. So make sure like you can have some understanding of what's happening. So yeah, for the chunks, for example, if I look at my chunks, if I pick a chunk randomly, it's very likely that I'll be able to understand the context of this chunk. So that's like very useful. Then the other thing was that I was using OpenAI for everything, which is very good. Like, I mean, it's a generalistic model. It's like, it does the job. But then I realized that, yeah, that's why I keep saying, that's why I keep talking about embedding models, is that the embedding models makes a big difference. So that's usually the second mistake you make, is that you just go for whatever embedding models that OpenAI has. And then sometimes it doesn't work. So then you're gonna try, to do like some very advanced things with your RAG app, whereas you could just change the embedding models usually. So those are like the usual twos.
Thank you. This is, I think, an appropriate last question. So we're just kind of going to do a last call. Could you summarize your presentation for RAG apps in 2 sentences? I missed the first 5 minutes, unfortunately, and it would be nice to have a nice closer.
Yes. You can use RAG locally with an LLM locally with like 25 lines of code. That's what I did.
Perfect. And for that attendee who joined us a little bit late, we will send you the recording so you can rewatch it as many times as you need to. Thank you everyone for joining us today and all of the really wonderful, great questions. Oh, sorry, we've got a last minute addition to the question about structured data, like in a large SQL database. To do a chat with a SQL database, for example, would it make sense to use Milvus?
So if you want to know what is, SQL database, then it's possible. You have to like embed what is in there, I guess, somehow. I know it's possible to talk to databases, I mean, to chat with them. So then as long as you can transform them and store them into Milvus, then yes. But you have to transform them content and the context.
Thank you, Stefan. Thank you to everyone who joined us. We will catch you next time. Keep an eye out on your inbox for the link to the recording, the notebook that Stefan walked through, and the slides. And feel free to join us on a future training or webinar. Thanks, everyone.
Thank you.